Good evening, everyone. Welcome back to the workshop. So today we are at the last day of the workshop, and today we are going to learn about the automation process using Nextflow. So before diving into the practical aspect, I want to discuss what Nextflow is, how it is going to help us, and what are the alternatives to Nextflow that are present in the market and how they are different from each other. And then we'll take up to the script. Let me share my screen. Okay, my screen is visible.
Yes, Ritika, it is visible.
Perfect. So, like from last 2 days, we were establishing a base so that we can understand what the RNA-Seq pipeline is. And today we'll talk about the automated workflow. So before understanding, before talking about the next flow here, let us talk about what is workflow management. So when we talk about bioinformatics, and in bioinformatics, we are dealing with the complex multi-step analysis, and we are also involving the data that is huge and the analysis that are involving numerous tools here. So like we can think of a situation that we want to process thousands of files, particularly FASTQ files all together. Like we have to perform the quality control, then alignment, and then quantification. The previous day, we talked about the tools, right? And we were trying to run one sample at a time. So you can imagine that if we have more than 10 samples, 20 samples, if we have 100 samples, so how this manual work is going to affect us. So it is not going to just be tedious, but we could have more errors, we could have more inconsistencies, and it can consume a lot amount of data. Sorry, lot amount of time here because we are dealing with the lot of data. Now, this is where the workflow management system comes, which is also known as WMS. So this is a way where we systematically design, execute, and monitor all the biological data sets requiring computational steps. Now, this workflow management system, it helps us to clearly define all the steps that we want to have in the analysis. And it is also able to handle the dependencies between the steps. Like if we are talking about the alignment, so before alignment, our quality control should be done. So dependencies will be like that before the alignment, the quality control must be finished. That is how it moves to the next step. It also efficiently organizes inputs, intermediate files, and also the final outputs. And we can parallelly run more tasks, which is going to speed up the analysis. And more importantly, we can track and we can reproduce the computational processes, make sure that there are consistency, and we have the research in the reproducible form here. Now, we are talking about workflow management system. So let's talk about that why this concept of automation is very important in bioinformatics. As we said that when we are dealing with a lot of data or very huge data is there, so there are chances that in manual doing of these steps, we can have some errors. They can be inconsistencies across the samples, and we can utilize, like we can take months, weeks to run the analysis for the entire samples we have. And also if sometimes it happens that one sample gives us one issue, others is giving us the another issue, so it becomes us more difficult for debugging and also the troubleshooting. So automation help us to save this time, and it try to get us the same results every time we run the analysis, right? And we can say the automation process provides us with the consistency in the result. It provides us with the efficiency in the result. We can automate the batch processing across the multiple tasks, and we can save our time. And also we can easily debug all the issues that we are having all together. And also we can run the pipeline anywhere, like we can say on the local machine or on the high performance computing clusters or even on the cloud. So that is what the automation provide us the upper hand of. Now, there are several tools for WMS. We have several options are available there. We have SnakeMake. The next flow is there, CWL and WDL here. So if you see, if you look at the comparison board here, so SnakeMake is Python based, and it supports the HPC support is there. It has the Python integration, but the limitation here is it do not have the cloud support. In the next flow, we have the language. It is a DSL based management system. And then it has the container support also, cloud support also, HPC support also. And limitation is that the learning curve for the DSL is quite complicated there. CWL, it has a YAML and CLI based container support is present, but cloud integration is not possible here. Then WL, which is designed by Broad Institute, it is domain specific. Strength is of cloud integration, but again, it has a limited ecosystem. Now, we are talking about all of these management tools that we have, but next flow, we are going to focus on the next flow here, as it excels in the modern scalable, and also it produces ready workflow, and it gives us the more comprehensive ecosystem, and also it moves towards the active community development. Now we have talked about several one. Let's make an introduction to Nextflow. So Nextflow, as we said, it is most commonly preferred, a powerful workflow management system for bioinformatics. It is used for automation and scale analysis across the computing environment, make sure that we have the reproducible pipelines. And the key feature that we can talk about here is that it is able to integrate all the real NGS tools, like we're talking about FastQ, HiSat2, SAM tools, Primomatic, that are actually required in the pipeline. Then we can generate some portable scripts also, and it can be executed on the local, on the cloud environment, and on the HPC systems. Now, why we choose Nextflow? Because Nextflow has rapidly become a go-to tool for large-scale reproducible bioinformatic analysis or bioinformatic workflow here because of its portability. Portability means we're talking about we can easily run it on the local system also, HPC clusters also, and also on the cloud platforms that are available here. It also has the strong support for the container like Dockers, and make sure, and like being able to be run on the Docker is that it provides us with the environment that makes sure that our tools, they are running in the isolated environment. Then reproducibility. Nextflow makes sure that reproducibility is guaranteed here. It helps to preserve the exact version of the tools and the parameters, logs, every run, and it nicely organize all the outputs that are there. Then comes the scalability. It intelligently, or we can say it nicely parallelizes the all task. It manages the large data set in such an efficient way that we can work across thousands of multiple nodes at a time here. And modularity, if we talk about the modular community here, so with its DSL2 syntax, it provides us with some of the reusable modules that can be backed up by the NF core community. So these are few of the advantages that Nextflow have, and that is why it is being used in the automation processes. Now, if we talk about the complete RNA-seq automation pipeline here, so in while we are generating the next flow automation scripts here, the very first thing is, as we can recall it from the previous session, the very first thing is what we did make the directories. We load the data into that using the wget command. And then from that particular directory, we use the fastqc tool. We got the trimmed files, and those trimmed files were used for the alignment purposes. And then from the alignment, we got the SAM file. The SAM files, they were converted to BAM file, they were sorted, they were indexed. And then those particular files, they were used for feature count quantification. So this is the entire workflow that we use when we are generating the scripts over here. So this was the introduction about the next flow here. Now let's move to the terminal and we'll learn about how we can prepare the scripts and how we can run them. Just give me a moment, I'll share my screen again. Okay, now it is zoomed enough. Now, if you remember, if I do ls here, you can see these are all the files that I got as the output that I did the analysis for the last 2 days. We have these particular samples, the FASTQ files are present here, and then we ran the analysis and we did all things, but we executed one tool at a time. Now we are talking about the automation. So the very first thing, as we talked about there also, the first thing is about the installation. So you have to install the Nextflow. I will share the command here. For my system, the Nextflow is already installed, so I'm not going to rerun it again. Okay. Here. So this is a curl command. Curl, and this is a link for the Nextflow io.io. So when you just simply paste this, press enter, and your downloading will be like it will begin and you will have the Nextflow installed in your system. Now for me, it is done. But after you have installed the tool and you want to check that if it is properly done or not, we can check the version, right? So for that, we need to have Nextflow version. Okay, so here you can see my Nextflow is downloaded perfectly, and you can see the version here. It was created on what particular date, and the citation is there, and they have given the link using which I have downloaded my Nextflow tool here. Okay, after if someone is trying on their system, please try, and if you face any issue, just to let me know. Now, in the workflow, we know that we are going to use several tools. So yesterday also, with the resources, there might have been addition of the commands that talks about the installation here. So let me share it again and I'll show you. So you can simply have this command sudo apt get install fastqc or sudo apt install fastqc, like that. For me, it's already done, so I'm not going to rerun it again. But for you, if you're doing it for first time, just simply use this command, press enter, and it will be done. But now here, what we can do is we can check the version, right? Fastqc version we can have. So you can see my FastQC is installed in my system, and then you can have a look at the version here itself. Now, if you want to install other tools, now you can use these. Okay. Now you can use the same command here, but now instead of fast QC, you can make use of Trimomatic, right? Now after Trimomatic, we need tool for alignment, which is HiSat2. Then after HiSat2, we need for sorting, which is SAM tools. And after SAM tools, we need the tool which is teacher counts. So these are all the tools that you can download in your system after like you by using this particular command sudo apt get install and then name of the tool that you want to work with. When all of this is done, like we can check the version also here. Okay, okay, if I say HiSat2, okay, so here you can see this is my HiSat2 version. That means it is also there. So that is how you can check the installation is proper or not. Once we are done with this, now the next step comes where we make a directory. So if you recall the presentation's last slide, the first step was to make a directory, and the Linux command for that is mkdir, mk make directory. And then after that, you can name anything. I already have my data in a specific folder. Like you can make your directory data, or you can name it as the project or the pipeline. So you can make your directory. Now, after making that directory, the next step comes where you want to fetch the files. So if you remember I'm inside the second data set. Yes, this is where I have downloaded my FASTQ files. I'll do the ls here. You can see these are my FASTQ files that I downloaded using the wget command. And then I pasted the FTP link from the ENA browser. So wget command can be used here. So we are only running it for one sample, right? That is why I have the forward and the reverse read here. Now, after your data is downloaded and you have everything, your tools are installed, your Nextflow is installed, your data is ready, and you know where it is. Now we are going to move towards the part where we are going to create the script here. So in order to create the script, the extension that we are going to use is .nf. So to create a script, we are not going to go back to the editor and going to create there. From here, we can use the command nano space and just think of a name. For example, let's see, we want to have, okay, fast QC .nf. You can see this is something we have here, right? Now in this scripting area, what we are going to do is we are going to prepare the automation script that we have, a bash script. I'll share the example here. For example, we are only going to use just for the demonstration purpose that how the file is prepared. Let me zoom out a little. Okay. I'm sharing it with you in the chat box also. Okay. I've shared the command in the chat box. So let me tell you what this all is. So whenever you prepare the Nextflow script, you can see the extension that we have used is .nf, and you can have the name as you feel comfortable and what you want to have. But here, if you look at, we are not running the entire workflow. This is just for the demonstration purpose, that how the script is prepared here. So I'm just having the part of QC, not the entire one. We'll do it in the next step. Now, whenever you prepare a script, the very first thing here is that you have to define this nextflow enable.dsl equal to 2. Now, what does it means? It means that we are defining, or we can say we are enabling the nextflow DSL2, which is going to support the modules, and it is going to have more structured workflow in the coming steps. So the first is all about enabling it. Then next here you can see PARAMS dot, how you pronounce it, params, we can say it like that. Params.fastq, then params.qc report. So this part defines that we are giving the parameters. We have to define parameters here, or we can say we have to define certain configuration parameters that are needed for each step. If you look at the FastQ, so I am defining the path. I'm defining the path of my FastQ file. If you remember, I am inside the data folder. If you look here, I'm inside the data folder here. And I'm defining that inside my data folder, all the fastq.gz files will be taken as an input. And this path I have provided here. Now I have created a QC report folder. This is another folder that I have created, which you can create using the MK dir QC reports, and it will be in a place where you desire it. So you can see it is in git test, inside the git test here, and there is another fast QC report folder that I have. So what I'm defining, that all my input files are present here, and you have to define the location or path of the file where you want to have your outputs. So now for me, this is the path, but when you're working with your own data, you might have another path, so you have to define it here. Now comes the next step, where we are talking about this process QC. Now we are starting with the process QC here, and we are defining this tag. And now publish dir, this command, what does it mean? So what happens here is, in the next flow, let me show you the folder here, this one. In next flow, what happens is all the output files by default, they are in the work folder here. You can see these are all the outputs of the next flow pipeline that I've run. So by default, everything will be in your work folder. But now if I try to open this like 82, what does it have? I do not know. If I want to have it in 86, I do not know what it is present here. So now this part here, which talks about the publish dir, it makes sure that all the results for the particular QC will be moved, right? Will be copied. Now mode I'm using is copy. So you can use the move version also, but it is not preferred, or it is not recommended, because during when you are moving your file, sometimes it might happen that there is not proper moving of the file is there, and in that case you might lose your original file. So what we do is we copy it. So publish dir, that means from this QC report, what we have generated, we want to move everything into this. So I am moving all the output from the work folder to the QC report folder, and for that I have given the parameter present over here. Now I'm defining that input. This is a syntax that is taken by a next flow here. You can see the process you are defining, then there is a curly bracket, you are defining a tag here, then publish dir command is present. Then you are defining the input for fast QC. What is the input? The FastQ files are the input. And then from here, the script, it begins. It says that I'm using the FastQC tool at the thread of 12, and my output directory is a QC reports whose parameters are assigned at the beginning of the script. And as a result, and this $sign FastQ mean that I want the output in a particular format. You will understand this when we talk about others also, because we know that as a result of a trimming, we are again going to get the FastQ files. So I'm defining what kind of output I'm looking at, and then I'm closing the bracket. Now, workflow is very important here, because you are defining that the input of the FastQ files will be taken as by the FastQ tool, and then it will be saved everything in your FastQ folder. So this is how we prepare a particular file. This is a syntax that is used by the Nextflow script. Now, when you have defined this, everything is just a small block. I'm just showing you how to execute it. When it is done, just simply press Control X. And you can see you have option to save, modify, yes. You can have yes and done. If I do ls, so you can see I'm having this fastqc.nf. Okay, my script is ready now. And now I can execute it. So now in order to execute it, first you have to give the permission to run it. So the command is chmod plus x and then name of the file, fastqc.nf. Okay, this is done. I've given the permission that I can execute this. I'm just copying it and pasting it in the chat box. Okay, after this is done, I'm going to run it. So now the command to run any of the Nextflow script that you have prepared is nextflow space run space then name of the file that you have, fastqc.nf. Now you can see my okay, what happened? Okay, it's caps nf. Okay, so now you can see this is launching fastqc.nf. And when I move to my desired folder, I'll show you my folder here, data. And here I have fastqc report over here. And this is how I'm going to get my output files here. So you can see these are two input files and these are two HTML files. That means I'm talking about the fastq file. So instead of running the command here, so this is one way of automation of one particular tool. So this is going to take around 10 to 15 minutes. I'm just going to cancel this. So I hope this is clear how you can prepare your scripts and how you can prepare how you can run the commands. I'll just recall everything. Using nano, you are going to prepare your script, type nano, name of the file .nf, enter, you paste the script in the desired format, you set the parameters Control X, and then you run it with the permission chmod plus X and the name of the file. And then you use the command which is nextflow run fastqc.nf and it will be done. So this is how you prepare and how you run your script. Now, we know that how we are going to do it. What is the syntax here? So let me discuss with you the detail. This is the Nextflow pipeline that we have. So it is going to have the similar kind of syntax, but now here along with the fastq, we have all the tools present and all the parameters that are for those particular tools over here. Now, if you look at the beginning here, so again, the script is starting with enabling of your Nextflow. Then there are a lot of parameters are present here. If you look at the param dot reads, that means you are assigning where your fastq files are present. 1 and 2 in the curly bracket, they are defining that we are making use of the paired end data. So for 1 is for forward read, 2 is for the reverse read. Then adapters, when you use Trimomatic, when you download this Trimomatic tool in your system, so you are going to get all the adapter files there. So I have provided the path of where my Trimomatic tool is present. Then I'm giving the indexing file. So if you remember yesterday, we downloaded the indexing file from HiSat2 website. So I have given the path of that particular folder, then GTF file, which I showed you that how you can get it from Ensemble and from the NCBI genome database. So this is the link for, or we can say this is a path for that particular file. And then I'm defining that where I want my output. So I want my output in the data folder here itself in the output. Inside the data, I have this output here. I want my folders here. Now here you can see we have so nicely defined different folders are there separately for FastQC accounts, BAM, HiSat2. So now after we are done with the parameters here, we are setting the threads also. Now next come the setting up of the directories, because you saw that how we have everything in the separate folders. So we have to set up the directories here. We declare a file to be output, which will be used to confirm the setup completion over here. So you can see I am making the script is defining here. The path I'm setting is setup complete.txt. I'm going to get this particular file as a result. And then script says that I'm making a directory, which is where inside the output, I want to have, I've defined this parameter here. I want FastQC folder, trim folder, HiSat2 folder, BAM and count folder, right? And then I'm using, this is that when the entire setup is completed over here, this echo file, it is going to log the timestamps that are there. So how much time it took. So it is going to give me that particular value in the form of a TXT file. So this is one, you can see the process, what you want to set up the directories. There is a curly bracket. You are defining the output, you are defining the script, and then you're closing the bracket here. Once it is done, then you move to the next step, which is process of FastQC. So again, publish dir so that everything is copied to the FastQC folder that we are defining here. Then what you want to use as an input, for the input, we are going to use the FastQ files. And here I'm using the tuple value. Tuple value is something, it is one of the function which makes use of the file name along with its path. So here, if you remember, every file is it's named by the sample ID. So what we are doing is we are fetching the sample ID along with the path of the particular read here, which will be taken as an input by the FastQ file. And we need an output here in the form of a HTML and the zip file. So if you remember, the FastQ file output are always in the HTML format along with the zip file there. Then if you remember the script here, FastQC, you will define the thread. You are going to get the outputs here in the form of the reads, which are again going to be the FastQ files. Again, you close it. Then comes the process of the Tramomatic, where we are going to trim the files here. Again, publish dir. Mode is copy. Input, again, we are going to use the sample IDs, the tuple values along with their path. And we want the output by the name of the sample IDs, but in the form of the now paired.fq.gz. So when you have the trimmed file, they will be named by this. So you will have a underscore paired.fq extension with them. So for the script, if you see here, we have a read one. We are defining the forward read. Read two is reverse read. And then they are on the basis of the sample ID that we have fetched. And this is something that we did yesterday. We are defining that we are using Tramomatic on the paired end data. You are assigning the threads. Threads, if you remember this, in the beginning of the script, you have defined this parameter. That is why instead of value, we are giving this particular threads over here. And then after that, you have to assign your forward and the reverse read. You can see these are your reads. You want the output in the form of the paired and the unpaired format. You're using this Illumina clip here. Parameter adapters again will be fetched from the parameters that you have assigned, the sliding window and Mendelin. So these are all the Tramomatic commands that we discussed yesterday. The bracket close, next come the HiSat2. Again, publish TIR. Input will be tuple value, sample IDs. But now the path will be of the trim reads. Because now for HiSat, we are not going to go with the raw files. We are going to go with the trimmed files that we have got after the use of the Trimomatic tool. So here we have to define that what path we are using. Now, as a result of the HiSat2, you want your output. But now we know that HiSat2 is going to give us the SAM files, right? So we want the output in the form of a SAM file here. So inside this particular folder, HiSat2, we are going to have the SAM file. Then comes the script here. We are defining the HiSat2 threads are there. And then comes this part of sensitive and very sensitive. This thing. Now, this is one of the parameter that we assign here. This is, we can say this is one of the option present that how we want to control the alignment process. So we can have, like, you have very sensitive, but we have other parameters also, like we have default, we have fast, we have very fast, we have sensitive, and then comes the very sensitive. So again, very sensitive is used when you are working with either you know that your data quality is very poor, or you have some splice reads are present, or you are working with the cancer samples, or there is a noisy RNA-seq samples that you have. Now, this is one of the parameter that gives us the more accurate result. But again, it takes some time. If you keep it in the default one, so it is just for the use, and this is for the like it's generally used, but it more contribute towards the speed rather than the accuracy, where highly sensitive one is where we talk about the single cell transcriptomic data in the similar way. Processing of single cell is different here, because for processing, mostly we use cell ranger. The data is processed there. We do not have, like, we do not do trimming or alignment. We do not go with that. Then these are other parameters. Again, the indexing file is present at the beginning here. And then we have other parameters. Now you want to have the output in the form of a SAM file also along with the TXT file. Now, SAM file is going to give us all the reads after the alignment, but we want to know that how much alignment stat is there. So for that, we are generating this TXT file, which will give us the what percentage of alignment is happening. So for this sample, 98 point something alignment rate is there, so that you can simply fetch it from the TXT file. Then again, bracket is closed. Then another tool, which is SAM2 sorts. Publish TIR, you want to give the input, which is the SAM file here. You want the output in the form of a BAM file. Then if you remember, yesterday we used view for conversion, and then we used the sort for sorting here, and that is how we got the sorted BAM file. After creating of the sorted BAM file, we move towards the feature count. Now, input we are defining is of the BAM file here, which will be present in the folder. The output we want in the form of a TXT file, the feature count file that I showed you yesterday. Here I'm assigning few parameters. I'm using the feature counts tool. Thread I'm assigning according to the parameters. Then I'm assigning the GTF file as an input. I want the output as a TXT file. And then this last command, it makes sure that BAM file dot join. Now, why we are using this join command here? For now, we are only using one sample. But for example, you are using the script for 10 or 20 samples, and you want to have a count matrix altogether. Yesterday, we only got for one particular sample. Today also, we are going to get for that. But when you are working with the multiple samples, you want to have at the end a combined matrix file. So that is why what will happen, all the samples that you're going to define in your analysis, in the end, you are going to get a joined version of the joint version of all the BAM files here, and you are going to get a combined count matrix. Now, at the end of entire script, you have to define the workflow. The workflow will help the script to understand that after what step, what will come, and how the output of one will be taken as the input of the other. So the workflow will be, the first is setting up of the directory. Then we are going to read the files. All the read files that are present here will be taken as an input by the fastqc, which will be stored in the fastqc results. Now the Trimomatic is going to take the reads as an input, and it is going to give us the trim reads now. Now HiSAT2 will be applied on the trim reads here, and we are going to get the aligned reads in the form of a SAM file. And the aligned reads is going to be taken as an input by the SAM tools. That is how we get the sorted BAMs. And then sorted BAMs will be taken as an input by the feature count here. And again, BAM_ch.collect. This command is making sure that here we use the join one. Here we are using the collect one. So it's the same thing, that we are going to get a combined matrix for all the samples that we have run in the end. So this is how you clearly define your script, and you add all the parameters in your script here. And it was created using the same method, nano, the name of the file .nf, and we have created the script and made all the changes according to the path of the different files.
I have a question here.
Yes, please.
So suppose like if we are doing for multiple samples, so the sample ID, like how does it pick up?
No, you are not going to define here. If you look at this, it's star. Star is like a wild graph.
It
We call it
selects all.
wildcard parameter, is it right? You just simply it is called wildcard here. So we are defining star underscore 12.fastqc, fastq.gz. So your all the input files will be there in one sample. One folder, right?
Yeah.
You're just giving the path to that particular folder, and you're asking that any file that is having this kind of suffix here, so it will be taken as an input. Because if you look at my files, like if you look at the files that I showed you here, I have this one.
Yeah.
This is the name of the sample, _1 fastqc.zip. The next is 2 fastqc.zip, like this. So that is why we have done a star _1 to fastqc.zip. So automatically it will read all the files. So we do not have to give the single input every time.
But for suppose this is the sample that is ending with 996, right? Suppose there is another sample which is ending with 998_1. So in that case, like I'm saying like there are two different samples having paired and data. So in that case, I just want to know like is it gonna take all forward reads once and then all reverse reads like once the forward reads are
No,
done?
it is going to read one sample at a time. So for one sample, forward read, reverse read. Next sample, forward read, reverse read.
Okay, got it. Yeah, thank you.
Perfect. Is there any common way to download all the samples in a single project ID or geo number? For geo number, no, you can use that command. I told you that from ENA you can have that a download script option is there. You can use this automated, like you have that ENA script, and then you can use chmod 077 077 and then name of the file. It is going to be some ENA file like this. Now, how I got this, when I go to my browser of ENA, there, when I was telling you that you can copy, at the top, there was an option of downloading all the samples. So it is going to have this sh script here. So chmod 077 and then name of the file. And when you enter this, all the samples in one project, you will be able to download at one go. But again, it is a time-taking process. But if you have that power, you can do that. Now, let me show you how to, let's end this with the next flow run. And then the script name was next flow. Updated. Okay, so you can see, right. So this is, you can see there are different. Yes, we are going to share that. Here, you can see the first step we set was the setup of the directory, then FastQC, then Tramomatic, then HiStats2. So it says that first step is done. The directory has been set up. As the FastQC will be done, there will be tick in front of it. When Tramomatic will be done, it will be tick in front of this. When the entire analysis will be done, you are going to have these folders here. And if I click on HiStats2, you can see the SAM file is there. When I click on FastQC, you can see along with the HTML files, zip files are present here. In the count, I'm going to have the count matrix, count txt file like that. And then if I have this trimmed file, so these are trimmed files that are there. So your respective folders will have the respective results that you can run for the analysis. Okay, any questions from here?
I have one question.
Yes, please.
So we just have to give that an address, right? That my
Yeah.
all files are here, and it will do the process then.
Not only about the one file, but for the all the files.
Yes, yes, yes.
In the
So in the
beginning,
script,
just
yeah.
these parameters you have to carefully define that my reads are present here, adapter is here, index is here, GTF is here, output, and my thread is this. And then it just will automatically fetch everything from the desired folders.
Okay, okay, right. Thank you.
So ma'am, are there cases, how do we take care of a scenario where we've done the first QC and trimmed, but the quality is still not so good, and we want to do the trimming again? Can we add that process, or?
You want to do the trimming again. So see, if you're not happy with the FastQC results, then what you
Yeah.
have to do is, yesterday I was explaining you that you have to be very stringent with your parameters here. You can
Yes.
change the number 4 to 20. You can like 4 base pairs less than 20. You have to define, you can increase this. So just try to play with the numbers here. These are few parameters that move towards the strong filters, or we can say the hard filters. So everything will be same, just make changes in these numerical values and you will see that there are some changes in your FastQC results also.
Okay.
Because this is a process of automation, right? So you have to define everything here. The first QC, then Trimomatic, and then you can add the QC part again here if you like to, and then you can perform the analysis.
Okay, thanks, ma'am.
Okay, so if no more questions, Javisha, you can take up now.
Ritika, there's a question in the chat
In the
box from
next
Subhadeep.
script can be run in Google Cloud. Yes, it can be run on the cloud. As we were discussing, that Nextflow has this option of like it's just compatible with the cloud, so you can easily run it there.
Thank you, Ritika. Are there any questions? Please feel free to unmute yourself and ask Ritika.